Hello everyone. GATE 2019 Civil Engineering Mathematics question answer discussion. Question number 1. Which one of the following is correct? Option A. Limit x tends to 0 sin 4x by sin 2x is 2 and limit x tends to 0 tan x by x is 1. Option B, limit x tends to 0 sin 4x by sin 2x is 1 and limit x tends to 0 tan x by x is 1. Option C, limit x tends to 0 sin 4x by sin 2x is infinity and limit x tends to 0 tan x by x is 1. Option D, limit x tends to 0 sin 4x by sin 2x is 2 and limit x tends to 0 tan x by x is infinity. In option C and option D, we see that the first part of the limit is infinity and in option D, second part of the limit is infinity. So these two options cannot be correct because we know this formula limit x tends to 0 sin x by x is 1 and limit x tends to 0 tan x by x is 1. There is no question of infinity. So remaining two, option A and option B, out of that, which one is correct? In both the options, the second part limits same values given. So the first part we have to work out. Let us work out limit x tends to 0 sin 4x by 4x multiplied by 4x multiplied by 1 by limit x tends to 0 sin 2x by 2x multiplied by 2x. So this part is 1 and that part is also 1. 4x by 2x is 2. Therefore option A is the correct answer. Question number 2, actually the question of core civil engineering, but from the mathematical point of view we can give the answer. Laplace equation in two dimension is del 2u del x2 plus del 2u del y2 equals to 0. Here also two directions x and z direction. So option C is the correct answer. Question number 3. A simple mass spring oscillatory system consists of a mass m suspended from a spring of stiffness k. Considering z as the displacement of the system at any time t, the equation of motion for the free vibration of the system is mz plus kz equals to 0. The natural frequency of the system is, we know that the natural frequency or the resonant of this given system is square root of k by m. So option B is the correct answer. Question number 4 is the expansion of Taylor series. Option A is the correct answer. Because in B there are minus signs, in C there is no factorial sign, and in D there are minus sign and also no factorial signs. The only option is option A. Question number 26. There are functions. We have to find the global minima, maxima. Let us take the first function and let us find dy dx. Making dy dx 0, we are getting x equals to e. And let us find d2y dx2. And putting x equals to e, we are getting d2y dx2 as negative. Therefore, at x equals to e, the function has global maxima. Question number 30. There are two functions. What is the value of del psi del x? From the first function, let us differentiate it partially. Second function also differentiate it partially, and from second function we are getting del phi del x. This del phi del x value, let us put in the first equation, and we are getting del phi del x as option D. Question number 44. Consider the ordinary differential equation x squared d2y dx2 minus 2x dy dx plus 2y equals to 0, given the values of y1 equals to 0 and y2 equals to 2. The value of y3 round up to 1 decimal place is. This is homogeneous ordinary differential equation given. We know how to solve this. Let us take x equals to e power z, then z equals to log x, find dz dx, which is 1 by x, and from here we can find xt as d dash, where d is dtx and d dash is ddz. And similarly, we can find x2 d2 as d dash minus 1. And now let us put these values xt and x square d square in the main equation. Then we are getting the auxiliary equation d dash square minus 3 d dash plus 2 equals to 0. And from here solving we are getting d dash as 2 and 1. Then we can write the complementary function. Now let us put e power z as x. Then e power 2z is x square. Now the conditions given when x equals to 1, y equals to 0. So let us put x equals to 1 and we are getting y as 0. So c1 plus c2 is 0. And then x equals to 2, let us put 2 to 4 c1 and 2 c2 and y value is 2. So we are getting 2c1 plus c2 as 1. So equation 1 and 2, solving those, we are getting the arbitrary constants c1 and c2 as 1 and minus 1 respectively. Then let us put these values of arbitrary constants in the general solution. Then we are getting y equals to x square minus x. Now let us put x equals to 3. Then we are getting 6.